Hello there. Um, so last time iterator, I changed the color scheme for the two languages, so I think this will help a little bit. But anyway, yeah, iterator. We were working on an iterator ability, and we got to here, and I said generic implementations were next, where we implement the ability for any generic type T. So that's what I'm going to try to do. I don't think I'm going to make too much progress. Oh, the color scheme doesn't stick. Okay, so that's not going to work. Anyway, let's get to it. Make it big. Okay. So I just worked out and I've had like 6 coffees today. And it's the middle of the day instead of the evening, so might be a little amped up this one. I just kind of want to get started. So the first thing I saw is that I have this check for if we've already implemented the ability. And I was doing that. So I was evaluating the self-type expression and the ability expression before creating the new scope, which doesn't work because if we look at iterator here, so, oh wow, that's fun. So I need to, it's amazing this runs for free. Okay, close that. And okay, now it's not happening. So scopes contain bindings, right? So I was running this expression and this expression before even making the abilities scope, because I was considering the abilities scope to only be like just to be starting here. But really, we need to say that it starts here where we can introduce our first bindings. So that's the first step, is moving the scope creation up higher. Pretty simple. I'm just going to trying to resize. I'll just yeah. Okay. So this would be the base ability scope. And in order to create it in the correct spot, I actually need the ability ID of the base ability. So what I'm doing is essentially just doing a lookup by name of iterable, not evaluating this whole thing, which is a little bit janky, but I need the ID of iterable so that I can make my child's scope inside the scope of iterable. So the order of operations is like figure out what I'm calling the base ability, then open up a scope that's a sibling of it, just so that they're neatly in the correct place. So that sibling scope, it's important so that it can see everything that the ability can see. I'm still not entirely sure if that's the right place to put it, but I don't want to change where the implementation scope lives. And right now it's a sibling, so I'm going to keep it as a sibling. So that means adding a child to the parent of the base. So yeah, because if I were to undo this, oh no. Yeah, it's a child of the ability scope. It's not a sibling of it. And that's so that it can see yeah, so that it can see these variables, I guess, and then it just binds them. Yeah, that's coming back to me. Okay, so this is correct. And now for each generic impl param. So we need to bind these. So we need to introduce t before we run those two expressions. And again, this is what's called the self-type. So this is this. And this is what's called the whole ability exper. That's this. I don't want to run that yet. Right now, all I've used from it is the name. Make sense? I still haven't fixed that thing. Maybe it's fixed. No update to blank, so I doubt it. Let's add a type. So we're introducing a type variable, which I have a function for, and that takes a type variable. I love fill struct fields, and it also takes a vector of abilities that this thing implements. Now that would go here. If I wanted to say, hey, only for t's that are something. For example, it has to be printable. So we'll call that constraints because we do need this. Let's see if we parse those. We do parse the constraints. So those are just type constraint exprs. Let's look at what we've parsed. So we parse, the only type of constraint we have is an ability constraint, and that's an ability expression. So that's going to be perfect. We'll evaluate that. So we'll just do, so the reason I prefer for loops instead of iterators for something like this is because I almost always need to use question mark when I'm passing through things, because if there's a problem in here, we can need to report up and just fail. And if I were to use closures and iterators, it's just kind of a pain. It's cleaner if the code never changes, but it really, in Rust, it just doesn't feel as good to use closures and iterators for these types of things as it does to use the for loop. So we're just going to do for parsed constraint in generic impl_param.constraints. And I will iterate this way because you're supposed to. Pedantic Clippy tells you you're supposed to. I really prefer calling .iter. So, and then we will do match parsed constraint. The thing is, there's only one type. It is an ability expression. And this is just self.eval ability expression. And that's the ability expression inside, of course, our new scope, inside the impl scope ID. Yep. And then that's going to give us back, if we question mark this, as I said, we're going to need it. That's going to give us an ability ID. So that's going to be constraint ability ID, just a nice name. And then we're just going to constraints push constraint ability ID. And then those would be the constraints on our type. So what that does is for later, you know, for code that later looks at the type T, it needs to know, hey, what abilities does T implement, like any other type? And that's why we need to pass those. So the name is going to be just the name of the parameter. So in our case, that's T. It's actually the ID of the string T in our identifier pool. It lives in the impl scope. And the span is going to be the span of the actual, so that span I'm using is actually this exact spot. So if there's a problem with this guy, we're going to underline right there. So it's important to use as precise of a span as we have. And now we need to store this. And we'll call it variable type ID to be precise because it's a type ID. And now we've done that. So that should be enough. No type to get rid of no type name T as in scope. Now, this NeoVim instance is not gonna do what we want. Right, so with a separate instance here, no type name T is in scope. So my goal here, undefined variable failed. Okay, echo message. Yeah, I don't know. All I did was remove the color scheme line. Okay, how about we just kill it and restart it? How about that? Oh, that doesn't work because we need to rebuild the LSP, which, okay, isn't working. So, my bad. What is wrong? No. No, 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 no. Wrong language. Oh my gosh, I gotta figure that out. So, typer. Sorry, I just missed that we still had errors. Oh, because it's... Yeah. Is that it? No. Uh-huh. Right, and then I'm using you later. So... I thought I was cloning him. I could just fetch it again. I think it's only the self type. So self type expression. So let me just do a little trick to not clone the whole thing. So we're going to say parsed. It's all internal stuff. I just don't know the first place I would, besides just disabling autocomplete, you know? Ghost text. Maybe I could disable ghost text. Parsed self type exper ID. And that's just parsed ability. Self type. Oh, okay. Yeah, I get you. We do need to clone those. But look, we're cloning everything else that it has. So let's just clone the whole thing. To do clone very coarse clone of best impl node. Especially since it includes the full function bodies. One of the big reasons not to do this too is that we could... No, there's no short circuit here. Only check if it's already implemented. Okay, so so this thing, add type, returns a Boolean telling us if the type already existed. And this actually is the place that we care about that because we haven't checked these yet. So if they used T twice, we want to know about it. So this will be if not. It's like we're writing C, and then that would be a grounds to return a failf. And then that's going to be on this actual param, and we're going to say name. duplicate name. And then we'll test that case. Okay, now it's building. So let's build the LSP. And start over. No type name T is in scope because I'm willing to bet we're not. So we're evaluating those expressions inside the parent scope, not in the new one that we just made that actually knows about T. So let's fix that. Try again. And look, we made it through the signature. Now we're here. Invalid implementation of next, wrong return type. Expected. A function taking a pointer to a list iterator of T and returning an optional item, but got a function taking a list iterator of T, a pointer to a list iterator of T, returning option item, opt T. Expected opt item, but got opt T. Param T is incorrect. Yeah. It should be item. That's how next works. They should be the same. Oh, but we haven't bound it. So, wait, item equals T. This is mind bending. So implement iterator for item is T. Yeah, this should be T. I think I need to run this because I'm not sure why it's not type checking. I think I need to bind T to something. Binding impl param item to T. This is fine. I don't expect this one to work. This one we can leave as int. And then we would want it to apply. So one step at a time. But this is almost too hard to do while talking and videoing. So our self type is list iterator T. We're implementing iterator where item is T. We're binding impl param item to T. And then we're going to check the function type. And we're looking here. So what should be happening is I should be binding item to t somewhere so that these resolve to the same thing. This code that's expecting item should look up item and find t, because it's an impl param, and then I'm walking them. I'm evaluating the type expression, and then I say binding impl param, and what that means is that in this impl scope, that impl param name, so item, should be equal to the argtype. And the argtype is type variable t. But then when I type check, printing out the message from type checking these two functions, which does give me both signatures. And the difference is just the return type, opt item and opt t. Expected opt item. This makes sense. But inside this scope, item should be bound to t. We get the exact same error, I think, with t. Whoops. And now with item. Expected type variable item but got t. It does the same thing. So item and t are clearly the same, but it's like it's a different t. Okay, right. So if we have two type variables, if they're exactly the same, otherwise I just say they're different. Oh. Oof, this is probably wrong. It's because I just did a substitute here, and I haven't evaluated them yet. But this is a scary thing to change. Okay, this is our happy path. Otherwise, we need to like resolve them, which is kind of what I do down here when it only one of the two is a type variable. I look it up and then I continue. So, and it's showing that it wasn't bound to itself. So I kind of want to do this. Well, also what I can do, I can kind of like print out the full state. So, let's print out like a scope. Scope. Yeah. maybe self scopes get scope scope id dot parent unwrap. So this is going to do is print out the scope and the parent right before things go wrong. And we see this is the scope and this is the parent. So let's start with the parent. Ability defen has no parent, I guess. It has a function called next, and it has two types. Item is bound to iterator.item. Self is bound to iterator.self. So they point to themselves. And now, here's our impl scope. It's called iterator impl for list iterator t. And it's of type ability impl, and its parent is iterator. And self is list iterator of it's like a different T. So item points to, oh, item and T point to the exact same thing, but they're not the same. Okay. Yeah, so we just need to resolve type variables as part of type checking. This is exactly what we want to see. Item and T are pointed at the same thing. This is a pretty big type because we expand it. But the point is that self list iterator of T, and that's RT. So does this look like it's list iterator of T. Yeah. Yep. I see. It's that T. RT. And for a listerator with that T applied, the buffer, yeah, it's the correct T inside the buffer, inside the list iterator. Okay. Yeah, I think it's correct. So I'll stop there, but like we have two types that obviously should be equal and they're not. So I'm happy with having found this issue. What I would probably do, I have to stop the session here. I would probably check that this works quickly, but then not fix it by just like looking up, like kind of copy paste what I'm doing in the other case where I look up what the variable points to and then recurse. But I don't want to duplicate the code, so then I would think, what's a more principled way to do this? Well, we can short circuit maybe like this and keep that, but then basically past that, somewhere higher up, if either side is a type variable, we should try to make progress on it. So look up what it points to. If it points to itself, stop, because that's valid. And if it doesn't, then if the right-hand side of the type variable, resolve until you can't look up anymore, and then we don't need to worry about type variables anymore for type checking. And then when we actually handle them, we can just check if they are actually the same. This should probably never happen. You know, this would make them the same, but anyway, that's what we'll do. Thanks for watching. If you learned something, to be continued.